So let me show you an example, and this is getting a little closer to stuff you'll actually be doing, or see on the assignments at least. If we have this circuit and we want to know what is the output of the circuit based on the input. So this is something, maybe I'll give you a few minutes to draw it down and think about it. And basically try to fill in this final table here. So based on what I've given you, so for each of these gates, the inputs and outputs, so the AND gate, the NOT gate, and the OR gate, what is the final output at Y? And, yeah, in the end you will end up with that. The example I made was 4, but... Yeah, so when you're doing these, in general, I mean, if you can either sort of look at it and try to analyze how it might work, but you can just go through is the recommended way, in that it's a simple procedure. So if we have A and B of 0, you can put A to 0, B to 0, and the output of the AND gate, 0, 0 to the AND gate, 0 goes there. So there's a 0 to the one input of the OR gate, and the NOT gate will invert this and give you a 1, 1, 0, so the output's 1. And then you can just go through for each other option. So I'll just erase all this. So again, the next one is 0, 1. So you can just write 0, 1. The truth table for the AND gate, the output is 0. Go through the NOT gate, 0, 1, and you end up with the same thing, 1, 0. So it's 1. If we put a 1 here, this next line, 0 here, the output's still 0, 0, 1. This gets inverted to 1, 1, 0. And again, the output's 1. Finally, if we have 1 and 1, so 1, 1 there, the output here of the AND gate, so you go to this line, will be 1. The 1 goes through the NOT gate, becomes a 0, 0 here, and this 1 goes down, and the output again is 1. So in this case, the output for all states is 1. So it's a very, very simple example, but you can follow that same procedure for more complicated circuits. So you can also directly write the Boolean function. And so the Boolean function is using these, so using y equals not A, y equals A and B, y equals A or B. And to do this, you just kind of look through it very slowly. And so, for example, we have A and B, so that's the output there. And this output gets split 2 ways. So one way is going to be ORed, and one way is NOTed. So we'll NOT that. So this point here is A and B inversed. And this point here is just A and B without the inverse. So then all we have to do is apply an OR to this. So when we write this out, we can say A and B inverse, ORed with A and B. And you can put brackets around it if you want it. And finally, you just have Y equals. Yeah, so the order of operations, we'll go through in a lot more detail, but you can think of it in the same way. The AND will have higher precedence than the OR. But I think for the most part, I'll always try to put brackets around it to make it obvious for now. So yeah, it's just the same thing that's showing the final result.